What's up, guys? My name is Anderson. I'm the developer of the Behaviour Machine, and I'm here to present you the first video about the plugin. It will be an introductory video giving an overview about how it works and what you can expect from it. I'm also going to talk a little bit about behavior trees and state machines, but I don't intend to get in detail. I'm actually going to focus on what the plugin is and what you can effectively do with it. Well, I think it is going to be very interesting to who bought the plugin and to who plan to buy it on the future. The first thing is to install the plugin. You can install it over here, download the package from the asset store, you access it through this window. However, I already got the package here, just double click it and port to your Unity project. Well, the installation takes a little while because it needs to import the package assets, so there are a lot of them, scripts mainly. They need to be compiled as well by Unity. At the end of the installation, you will have a new folder on your project. That is this folder called plugins. Inside it, we have two other folders. On the first one, we have all the runtime scripts. They are the scripts that are in fact included on your game. While on the second folder, we have the editor scripts, which are used by Unity editor to, for example, render windows and menus, among other things. After the installation, it's going to appear a new tab over here. It isn't here yet because Unity has a common bug that causes this, but as soon as you click on any tab, the Behaviour Machine tab becomes visible. This first option opens the main window of the plugin. I will click on it. It doesn't have anything on it yet. I will leave it down here. On this video, I'm going to rebuild this scene. On this scene, you are this character and use the keyboard arrows to move around. Let's see how it works. Here I'm using the keyboard arrows and the character is moving, and there it is. I won't write a single line of code to do this. I will use only behavior trees and state machines to do it. So let's do this. I will create a new scene and set up it quickly. This scene has the constructor character. I will place him here. It also has a plane and the light. I will place the plane on the origin, break the link of the character's prefab. I will add a character control component to it, which allows us to move it and place it above the floor. Let's get the camera a little bit closer as well and rotate it. Yes, it's good enough. So to get the player's input and move the character, I use a behavior tree, and to make the character trade between the idle and walk animations, I will use a state machine. To add the behavior tree, you can add it as you usually add any other component. Its name is behavior tree. It's here. You can also use this window down here, right click on it and add this first option. Done. As soon as you add the component, this other one called blackboard will be added as well. This component stores some data that will be shared between the nodes of the tree. This data will also be shared between other trees that you may eventually add to your game object and between the state machines too. Now this window is showing the data from my behavior tree. That means the nodes from my behavior tree. This is the name of the tree. I will change it to controller, and here the tree comes with two nodes, the onEnable and the update. If you are a programmer, you probably already know what they do. When you select one of them, you can visualize its parameters here on the inspector. Up here we have the tree's parameters, which are the same showing here on the GameObjects component. If you hover over the node's name, you'll see a little description of what it does. Both of them are special nodes, called function nodes. They will run their children during specific events. On this case, the onEnable will run its children when the tree is enabled, and the update node will run its children every frame while the tree is enabled. So to give an example, I will add a new node to the tree called log. There are three different ways to add a new node to a tree. The first one is actually the one I like the most. You right click the node you wish to make the parent of the new node and search for it on this first option, where we can see there are many different categories of nodes. I'm looking after this node called log. The second way is to click on this option to open a window, and here I can select the node I want to add. This window is interesting because it will show the node description and the parameters that it will show on the inspector view when selected. The third way is to search for the script name and drag it over the node you wish to make its parent. Okay, it's done. This is my log node. This node prints a message on Unix console, which is this window. You can select it by clicking here. This message parameter is the actual text that will print on the console. If you click this button, you can set the text. I'm going to be really original here, or not, and it's going to print this hello world message. If we run our tree by clicking play, it will be enabled and the onEnable will run its child to print that message. There it is, our hello world message. It is good to note that the update node is highlighted. Every node that runs will be highlighted for at least 1 second. And it is red because every function node needs a child to run. And our update function doesn't have one right now. So I'll drag the log node over the update function and it will be added to it. Now we have the message being printed every frame on the console and the color is now green. I can change the message here, and the cool thing is that when you exit the play mode, everything reverts to the original state. It reverts to what it was before we entered the play mode. This works with everything on Unity. It's great because you can play with your tree, change the parameters, add and remove nodes, and as soon as you click play again, everything reverts. Now I will continue to make the third person controller right, because we can't actually make a game by only printing console messages. So the first thing we should do is to get the input data. That is, get the arrow keys input. For that, I'm going to use a node in the input category called getAxis vector 3. This node gets the data from the axes you configure on Unity. By standard, the horizontal and the vertical axes are mapped to the arrow keys and to the joystick. And over here is where I can store the input data. For that, I'm going to use a variable from the blackboard. The blackboard is meant exactly for that, to store data. To create a new variable, you can click on the plus icon here, or you can use this plus icon right down here. I will add it over here. A variable of type vector3, name it axis. And over the get axis vector3, I will start that input data on this new variable. I can click on this variables bar to show or hide our variables as well. Now, to move our character, I will use the character controller component. For that, there is a node on the character controller category called move. This node can make your character move by using its character controller. This parameter is the movement direction. I use the data we got from the arrow keys input to move the character to that direction. Let's hit play to see how it is now. If we press the arrow keys down, the character moves, but it's not very good yet. There are two issues. The first is that the character is not facing the movement direction, and the second is that the character doesn't change between animations. Uh, well, to solve the first issue, you can use a node to rotate the character so it faces the movement direction. So I will add this node here. The new direction parameter is the same as the one we got from the input, and here is the speed. I will put 60 degrees per second. And now, when we enter play mode, the first issue has been solved, but it still keeps playing the same idle animation while moving. To solve this, we have plenty of options. We can do it through the behavior tree, we can use mechanism to do this, but I'm going to use a state machine from the plugin to show you how to work with state machines. To add a new state machine to a game object, we can do the same as if we're going to add a behavior tree, or it's just a component. So I add it. Done. I will call this state machine animation graph. Now, to see its contents on the behavior window, I will right-click the controller icon. For now, the window is showing the controller info. I wanted to show the info from the animation graph, so I just selected, done. Now I see my state machine. For now, there is no state. I will just add a new one. Right-click and select the behavior tree. What is interesting about it is that you can treat a behavior tree as a state from a state machine, and also have a state as a node from a behavior tree. So you can combine these decision-making methodologies without problem. I will call this node idle and a new state called walk. The idle state will relate to the idle animation, and the same with the walk state. Another interesting thing here is the color of the states. The walk state, for example, can change its color. You can put wherever you want here, yet the idle state doesn't have that option. It will always be orange because it is the initial state, the first state to become enabled on our state machine. If you already work with mechanic, you would already have guessed at that, but you also can change the initial state if you want. Just right click the state, select this first option, and then you don't see the option to change its color anymore because it is now the initial state. Now let's edit the states. This behavior tree is starting by the idle state. If you double click it, you'll see its info. If you click again on the animation graph, you'll return to where you were before. Here are the two nodes, onEnable and Update. What I want is that when this state becomes enabled, it plays the idle animation. For that, I've used a node. And I will copy this node to the walk tree as child of the onEnable node. But I want to play the walk animation instead. These two animations are here on my character, idle and walk. Let's see what happens when I enter the play mode. Here, this state is enabled. It has this bar showing that. I can also visualize it here by the name. It will show here as well if I click on the gizmos icon. So the enabled state is the initial one that tells the character to play the idle animation when it's enabled. But the issue still persists. What I want is that when the character starts moving, the walk state becomes enabled. I can force that by selecting the second option. But then it will always be walking like this because there is no going back transition. So there are missing transitions between the states. I will add these transitions here. For a transition to occur from a state to another, it is necessary an event to trigger. So I will add here two events. One called to walk and another called to idle. Sorry. I will also associate this transition with the to walk event and this with the to idle. This means that when the event to walk triggers, this transition will occur. That is, the idle state will become disabled and the walk will become enabled. The same here. When the event to idle triggers, this transition will occur and the walk state will become disabled and the idle will become enabled. Now, how do we make this event to trigger? Note that all we need to know is if the character is moving or not. If it is moving, I want it to go from idle to walk, and if it is not, from walk to idle. The obvious parameter is the character speed. Then, if it is 0, then the idle state must be active. If it is greater than 0, it must transition to the walk state. To get the character speed, I use our controller tree and save the speed on the blackboard. I will add a float var I call it velocity, and I add a new node to the tree and the character control category. It's that one here. Well, I want the horizontal velocity. Done. Now, entering the play mode, you'll see that when the character is not moving, the velocity variable is 0. But it changes when it starts moving. So I will just use exactly that to make the transitions work. I will use a condition that will run every frame called isFloat greater. Is that node here. I will add to the tree. If the velocity value is greater than 0, I want a walk event to occur. This node does exactly that comparison between the value of velocity and 0. Every condition node will have a yellow label that here in the tree has this onSuccess parameter. That parameter allows you to select an event that will be triggered when the condition is true. That is, when the velocity is greater than 0, the event to walk will be triggered. So the transition will go from this state to the other state. And on the walk state, I need another condition to trigger the event to idle as well. I go under condition blackboard and isFloat equal. When the velocity is equal to 0, I want the event to idle to be triggered. So when the event is triggered, this transition will occur. Let's see it working. Right, our character changed its animation correctly now, and we also have a visual feedback over here in the behavior window. Look at the transitions go green when they occur, from the idle to walk and from the walk to idle. So it's working. I didn't need to write a single line of code to create this third-person controller. I only created this animation graph, and it's possible for you to code your own state if you are programming, since a state is nothing more than a Unix component. So by programming, you can code your own state with its own awake, update, and fix the update without any problem. I'll make a video showing that as well, but I believe that with this video you can have an idea of how everything works. I'm sorry if I wasn't clear enough at some point, because my goal here was just to give you an overview on how you do stuff with the plugin. In the next videos I explain in more detail things like how to create a behavior tree and more advanced concepts. So that's it. I thank you all for the interest on the plugin and for watching this video. See you next time.